Okay, so on to our next design principle now, the O of Solid. This stands for Open-Closed Principle. Now, the idea with this principle is that a class should be open for extension, but closed for modifications. Now, what does that mean? That means when adding new functionality to a system, you shouldn't have to change too much existing code. So you shouldn't have to be modifying lots of existing methods and existing classes. When adding new functionality, you would want to be creating new classes with new methods. So this means as you add features to a system over time, add functionality to a system, you're not going to be disrupting existing code too much. If you find yourself modifying a lot of existing code each time you add a feature, then with each change you're introducing a new level of risk. You risk breaking that existing code as you're forced to change that logic. Whilst keeping things separate, you'll just be testing the new behaviour, your new classes that you've introduced into the system. It makes it far more likely that you're going to be able to get these changes right, you'll be able to perform these changes a lot more efficiently and a lot more safely. So let's look at an example of this now. So sticking with our shapes example, let's imagine we've got some editor of some form that allows us to create a drawing out of our shapes. So one way you could do this is have a drawing editor class with a draw method and then a few private methods, one for each type of shape that you wanted to be able to draw. So you might have a draw circle, draw rectangle. Now, this drawing editor class, it violates the open-close principle. And the reason for that is every time you want to add a new shape to the system, you're forced to go back to the drawing editor and modify that existing code there. So each shape you add, you risk breaking rendering of existing shapes in the system. So every time you change it, you're going to have to go back and test more and more each time, as you've got to test that existing functionality hasn't been broken. So a far better way to do this would be to have a drawing editor. It still has that draw method, but what it does is it delegates to something which implements a UI element interface that you've introduced. So the UI element interface, it describes something that can be drawn on a user interface, hence the single draw method. And what we've done is we've introduced separate classes for the UI components of our shapes now. So we've got a rectangle UI that knows how to draw rectangles, and a circle UI that knows how to draw circles. So adding a new shape now is a matter of creating a new implementation of that interface. The changes to the drawing editor are now going to be very minimal, and in testing terms, you're just going to be testing your new class that you've created, your new UI element implementation. So there'll be far less code in the drawing editor, it's going to be far easier to maintain, and there's far less risk involved in adding new features, new shapes in this case. And as far as test-driven development is concerned, you'll find this is going to be far easier to develop rather than having to worry about testing every element of the drawing editor. You'll be creating these new classes in a test-driven fashion. So again, your testing will be very focused, very directed, purely around the new changes that you're introducing, the new functionality that you're providing.